What's up guys, welcome back to my channel, and today we will be solving these two math problems given right here. So apparently in this video I will be only doing the first problem. So let's go through the problem first of all. For any positive integer, x is greater or equal to 2. Define Fn to be the product of the distinct prime factors of x. For example, f12 is equal to 2 times 3 equals 6. So the thing meaning here is that if we take any integer and if we write it as a product of prime numbers, we can simplify the same prime number as an exponent, right? So it'll be like 2 to the power 2 times 3 in this case, or 12. So here the bases are 2 and 3, and those bases are the prime factors here. So those are the prime factors that are multiplied to get 6. So we're supposed to do this task. We're supposed to write all the integers for x where 2 is less or equal to x and x is less than 100, such that fx is less than 10. So which means the final answer is less than 10, but the number subjected to the function, or the number written with the f, is between 2 and 100, where 2 is actually possible for x. Now, generally in between the first and the final number is cancelled off. That's why I said that. So, without chit chat, let's move on to the problem. So, first of all, if you can solve it, pause the video and solve it, because I'm going to solve it right now. So first of all, what I'm going to do is I'm going to write down an inequality for fx. So here it might not look like fx, but here fx is a product of certain integers, right? So I wrote a times b times c and so on, any number of possibilities is less than 10. So these products are the only products possible for this inequality. 2, 3, 5, 7, and 2 times 3. Now 2 times 5 looks like a solution, but this doesn't have the equal sign. Instead, it's just less than. So we can't take 5 times 2. So now we have that particular value, and now we are moving on to this first inequality we had in the first place. 2x 100. Those were the 3 terms of the inequality. So if we take the second number and the third number of the inequality, x 100, the inequality between them is x is less than 100. So I'm going to use that to solve this problem. So x can be any number created using these integers right here, 2, 3, 5, 7. But there are some rules. When you write 2, 2 is the only number that should be in the value. 3 has the same thing, 5, 7, all of those have the same thing. And then once 2 times 3, the only 2 numbers that can stay in there are 2 and 3. So now let's move on to our problem. So first of all, what I'm going to do is I'm going to go to this 2 right here. And I'm going to write 2 to the power n is less than 100. I'll explain to you why. So now, let's see how many numbers we can write down for 2 to the power n so it doesn't exceed 100. So we have 2 to the power 6, which is 64. Now let's go to 2 to the power 7, which is 128, which is bigger than the value that we are looking for. So which means we can stop simplifying for 2 to the power n right there. So which means there are only 6 values for n, which are 1, 2, 3, 4, 5, 6. So which means the values for 2 to the power n are 4, 8, 16, 32, and 64. So these 6 numbers are some of the integers that they're expecting us to write for the answer. So now we have a ton of more numbers to write down in this section. So now we are gonna solve more numbers. So now we're moving on to 3. So which means here it's the same explanation. 3 to the power n should be less than 100. 3, 9, 27, 81. These are the numbers applying for 3 to the power n. Now I use the same concept here, so hope you understood that. So now we found 10 numbers suitable for this entire inequalities. So now we're moving on to 5 to the power n less than 100. So here we have 2 possibilities, which are 5 and 25. So now we have 12 numbers, but still I'm not done yet. Now we're moving on to 7 to the power n, which particularly has 2 numbers, which are 7 and 49. And now we have 14 numbers, but still we have one last product, which is 2 times 3, which has a value of 6. So because of that, now we're moving on to 6 to the power n. Although we have 2 times 3, first I'm moving on to 6 to the power n because this final equal value here is 6. But still there are more, okay? First I'm going to find 6 to the power n. So guys, here I only have a few possibilities actually, where there are only 2, which are 6 and 36. Because 6 cubed is going to be much more larger. So 6 and 36 are those relevant values. Now we are moving on to the hard one. 2 times 3, the left side of this expression. Now in all of the previous 4 ones, the left and the right all were equal, but now here we have 2 different values for both of the sides. 2 times 3 and 6. I mean, I know the value is same, but I'm just talking to you guys about the way it's written. So 2 times 3. So now here what we have to consider is there are different types of possibilities for 2 times 3 equals 6. So which means here that those particular numbers should be multiples of 6. And why am I mentioning that? Because now here there should be at least 1 2 and 1 3. So which gives us a final conclusion that those values should be multiples of 6. So which means the numbers in that part should be elements of the number pattern 6n. Okay guys, so I wrote down that expression right here. So now we can find values for n. Sorry, it should be m right here, otherwise it's going to be chaos. Because here in the left side we wrote n already. So now we had to find values for m. So m can have different values, where there have to be multiples of 6. So we can write down values for m as 6 and 12 and 18 and so on. We have possibilities till 96, where 96 is 16 times 6. So which means they are 16 terms which are elements of 6n. So here I forgot to write one particular inequality, which is m is less than 100. Yeah, that should be definitely there, otherwise it's completely wrong. So now just like that, I found all of those values in there as well. So the very first thing I'm going to do is I'm going to take these values of 6n, where there were only 2 values, which were 6 and 36. So let's think we took out the 36 from the center. So Now we have 12, 18, and so on till 96, all the multiples of 6, but without 36. So let's just put it like this, just to be safe. Yeah. Now it's much more better. So now we have that entire expression right here. So okay, now we found out all of the values which are suitable. So here we have 12, 18, 24, and all of those values here where there are 14 terms. You have to remember that. There are 14 terms in there. So here we have 6, 4, which is 10, and we have 12, 14, and 16 terms. And with these 14 terms right here, it's going to be 30 integers. So there are 30 integers suitable for x. So let's write down all of these 30 integers we just discovered. And just like that, we found all of the possible values for x, which are integers, and x is between 2 and 100. Sorry, between 1 and 100. And the product of their distinct prime factors is less than 10. So I hope you guys had fun solving this math problem. Make sure to subscribe to my channel and share it with your friends. And I hope to see you guys in another video where I will be solving the second problem of the same set of problems right here, the problem B. Take care, peace out.